Hi everyone, welcome back to Educase. So today we're starting a new branch of chemistry, which is organic chemistry. So in the course of this series of lessons, we shall go through these topics. Topic one, introductions to organic chemistry. In this introductory part, we are mostly going to see the nomenclature of organic compound, or how can we name the organic compound. In fact, it's all about nomenclature. So topic two are hydrocarbons. Hydrocarbons have alkanes, alkenes, and alkynes. We all know that hydrocarbon is a compound that contains only two elements, carbon and hydrogen. After that, we'll be to topic three, it is the aromatic compounds. We'll talk about aromatic compound, we'll talk about benzene. So benzene meaning we have topic five, which is alcohols, phenols, and ethers. 6. Carbonic compound. Carbonic compound, you will talk about aldehydes and the ketones. So, our carboxylic acids and their derivatives. They are forming carboxylic acid derivative. VAB, acid chloride, amide, acid anhydride. VAB, acid anhydride esters. Nicabidine, acid anhydride, acid chloride, amines, esters. So these are the four main carboxylic acid derivatives. So after carboxylic acid derivative, we have organic nitro compound. The organic nitro compound have the amines, the nitrates. So both you have amines and nitrates. So after amines and nitrates, as a bonus topic, we shall see organic synthetic base. So why an organic synthetic base? An organic synthetic base will enable us to move from one homogeneous series to the other. So that notwithstanding, we'll go straight to chapter topic 1, introduction to organic chemistry. When a newborn baby comes this world, the first worry is to give him a name. The name of the baby depends on several factors: the origin of the family, the lineage, and all the rest, the ethnic groups, and all the rest. In chemistry, you see, whenever chemists synthesize an organic compound, they have a very big worry. Which name are we going to give to this compound? So, the name giving is not done in a haphazard manner. So, for you to give the name, it follows a chronology. So, this chronology in chemistry, organic chemistry, call it the EUPAC system of nomenclature. What EUPAC? What you see in Pakistan, EUPAC stands for International Union of Pure and Applied Chemistry. So, in this association, it's a decision of chemists that give the various rules to be followed in nomenclature of organic compound. So in this case, in this topic, I'm going to build the rules and we're going to apply the rules. And the kind of giving the rules, there are some exceptions that we shall take into consideration. So let's say we have an organic normal like this. This is an anival. In this case, the organic compound have 4 boxes. I'll call this box carbon. So we have an organic compound have 4 carbon, add the 2 carbon, the 1 carbon. The nomenclature will be done in a systematic way. So the number of carbon you have prefixes. So this is the first rule. So we know the longest carbon security. the longest carbon skeleton. So I'm going to give you a table. So in table, you have a primitive. It ends 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the RAM will stop at 10 hours. And university can go up to 15 hours. It can go up to within 20. University you can have compound with even 3 benzene ring. That is possible. So let's come here the table. So in the table, we have here prefixes. If the compound has carbon, it takes the prefix mate. Mate. So is co, but, pent, hex, hept, oc, no, de. So this is the number of carbon and the prefixes. It's 1, say mate, 2, say 8, 3, say pro, 4, say put, 5, say pence, 6, you say hex, 7, hex, 8, oc, 9, none, take, 10, take. So what's the physical significance of that? Consider this organic compound involved. So I'll give you 2 organic compounds. So have the first one CH3, CH3, CH3. The compound is an alkene. How do I know that the compound is an alkene? The compound has single bonds, no substitute. So count the number of carbon. In this case, you don't have any substituent, so you can start naming the organic compound either side. So given that the compound it has no substituent, so I can start naming here 1, 2, 3. We'll come out to the 2, 3, it pop. But here there is an alkane. We're going to take coke, which is a prefix, and add to the end of an alkene. So given that is an alkene, this is where it stresses. We're interested, sorry. So we say co for pain. So the name of the organic compound is a prefix plus the name of the functional group. So here you can say crop. Then let's take an organic compound with 4 carbon. So here we have CH3, CH2, CH2, CH3. In an alkene with how many carbons? So let's count number of carbons. 1, 2, 3, 4. 4 carbon come with we have bits. They say bits. They say bits. Plus the end of the alkene. That's why it gives us the T. So the name of the organic compound is made up of 2 parts. The prefix that indicates the number of carbon and a suffix that indicates the functional group. You can have the kind of an alkene. So let's take an alkene. An alkene, the compound have double bond. This is an alkene. What happened to an alkene? So let's take an alkene. An alkene. Alkene is CH3, CH3, CH, double bond, PHC. Do you think the nomenclature of an alkene is the same as an alkane? Is it possible? Have 2 different homologuses or functional group. In this case, we'll have an alkene. So the alkene is finishing with E. But alkene now has a small problem. It has a double bond. The double bond can be either side of the organic compound. So the double bond, it can be here, it can be here, it can be here, it can be here. For an alkene, we are going to indicate the position of the double bond. So very, we'll say but 1, 2, 3, 4. But because it has 4 carbon. In an alkene, so say butene. This nomenclature butene is acceptable at the ordinary level. So you can say butene at the ordinary level. Around level, you need not to say butene, but but 1 in. So if with 1 in here is that you are indicating a position of the double bond. You get a double bond, you have 1. We have 1, 2, 3. Double bonds of position 1. So that's what's it. 1. Okay. So that was the first rule. Rule number 1. The number of carbon in the organic compound. So let's go to rule number 2. So rule number 2, the position of the functional group. Like I was talking about the alkene seals or the alkyne seals. So the position of the double of the functional group is indicated using an Arabic numeral. So we use an Arabic numeral to indicate the position of the double bond. So see what we do. We can handle organic compound. CH3, CH, double one, CH, CH3. Another one CH3, CH3, CH, OH, CH4, CH3, CH, C, theta bond, C, CH3. Let me not talk about. Let me just. Here's 11 of alkenes. I can put the double bond. So see the organic compound we got. We have 2 types of organic compound. We have an alkene characterized by double bond. We have an alkyne characterized by a triple bond. That's beautiful. So we'll count number of carbon. 1, 2, 3. Yeah, we don't just count the number of carbon abandoned. We take into consideration the position of the functional group. Like here, the functional group is in the middle. That's why I'm counting from either direction. The functional group is in the middle. But for the one you see a functional group is at the end of the chain. That's why I'm saying I'll count where the functional group is found. So 1, 2, 3, 4. 4 carbon have the group prefix. Good. The why is the double bond count? Double bond for position 1. So yeah, double bond. I would say but. That's why we're going to say but. 1E. So we go A. So let's sing on me, guys. 1, 2, 3, 4. I will think when the say we 1 in. Where's the double bond from? So let's count the position of double bond. 1, 2, 3. The double bond is all position 2. It's still a concoupled bond and it's an alkene. That's why we did but 2 in. So let's count back to the last organic. I do regard that we start counting where the functional group is found. So start counting this. 1, 2, 3, 4, 5. That's why I started counting here, but this is where the double bond or the triple bond is found. That's very cool. So here I'm going to say paint. Why paint? The number of carbon now is normal for it's 5. That's why I'm saying paint. So saying paint now, I'll say paint what? 1, 2. You see the triple bond is on position 2. That's why I said paints. So I no more in, there's ein. Why? Because an alkyne, alkene, alkanes, the nomenclatures are not the same. Okay, I have a small a small tip on giving you the nomenclature. So consider this organic compound. So here is a bit tactical. The organic compound is a bit CH3, C, maybe the double bond here, yes, H, CH double bond CH. Voila. You see, this compound is not like the other ones, even though it's similar. The compound now have two double bond. So what? The first double bond on position 1, the second double bond on position 2. So let's count them up. Come on. 1, 2, 3, go. 5. So unit 5 is paints. So paints. What is the double bond from? So 1, 2, 3, 4. The double bond is found on position 1 and on visibility. That's why we say pins 1, 3, diene. And pen 1 to diene. Diene simply means it has two alkene group. The double bond is on position 1, position 3. That's why we say pens 1, 3, diene. Okay. This is rule number. This is rule number 2. See, we're just in rule number 2 and I've learned many things. The first rule was to know the number of carbon and we associate to the number of carbon a prefix. The second now is to give the position of either the double bond or the triple bond found in the organic compound. So I get it two types of organic compound. There's an alkyne, there's an alkene. So in this case, we have two alkene group. That's from say paints 1, 3, 10. So we'll go to rule number 10.